So, all the way from Barcelona, Guillem is presenting his research. Guillem is the director of the Robotics Institute, and in assistance robotics. So this is basically what you can see from the first slide. So, and we are here in. This is a talk before lunch starts, so we have to be finishing in time because the restaurant asked us for joining or going to the lunch early.
So you are challenging me to do.
Okay, no pressure. Thank you very much.
No pressure that much. Okay, thank you so much for the nice presentation. As I said, I'm director at the Institute of Robotics in Barcelona, and this is a research institute, basically in robotics with 4 research lines. Before starting, I arrived yesterday afternoon. I don't know if you made a brief presentation, but I would like to know a little bit more about you, just to try to shape a little bit my presentation to the interests of everyone. So, as it's impossible to make a one-by-one presentation with this huge audience, I'm going to make some questions, and I want you to raise some hands. For example, who is doing a PhD here? Okay, and from those, who is starting the PhD? Just first year, or maybe beginning of the second year. So I assume that the rest of you are already finishing, you already write papers, and you already are thinking on writing the dissertation, isn't it? Yeah? How many of you come from the perception mainly, or your interest is in perceiving and understanding the environment? Okay, and how many of you on control robots? Okay, and how many of you on taking decisions? Okay, I assume I see people not raising hands, so I don't know what to think, you know? What are you doing then? Okay, how many of you already have used robots in your real life? So real robots, okay, well, that's perfect. And how many of you have done experiments, not only in the lab, but in real environments? Okay, not bad. And how many of you are, to decide these experiments in real lives, are relying on third parties, on other people, on companies, or in hospitals, or in end users? Okay, not that much. And finally, how many of you include people on your experiments? Okay, so then maybe it's interesting, because this is what I'm going to talk about in the next hour. It's how we add people to our experiments, and how adding people is interesting for us, because it raises a lot of very interesting problems to our research. So first of all, just let me do a brief presentation on what we are doing, if this wants to work. Come on. Really? Okay. So as I said, we are in one of the labs of our institute. This is the Perception and Manipulation Lab. This is the biggest lab the biggest research group in our institute, more or less 50 people. So we do robot manipulators in human environments. As I said, that's very important. So we have people that master, or that his interest is in decision making and learning. For other people, this is on the planning, so on deciding what to do, and for other people is on perception. So basically, we have people working on all these different aspects, because we think that the real solution comes as a global view of everything. Yeah. So having in the discussions people from different areas or interests is really beneficial for us. Okay. And we do robotics and artificial intelligence, of course. So we are kind of in the middle of these 2 areas. And where are we applying? So this is the research that we do, and now how we show that this is working. So we showed that this is working in 2 different areas. First one is manipulation of deformable objects, because this is a very huge state space and has a lot of interesting problems. And the other area is in assistive robotics. Okay? And today I'm going to talk about this second area, not this first area. And in assistive robotics, putting humans in contact with robots, we have a lot of issues. There is one part that is social, in the sense of acceptance, in the sense of building trust with people, in the sense of how we measure that things are effective. And for that, we are using a lot of methods and theories that come from social sciences, but this is not what I'm going to talk about today. So today I'm going to talk about the other part, okay, the engineering part on how we basically make the organization of the information and how we use that for shaping the use of robots, okay? But if you want to learn a little bit more, you know that you can look for all this kind of stuff in our webpage. So let me start with these nice videos. You see here robots doing different things and doing things in a different manner. You see, for some of them, they already have finished to feed it, for example. For some of them, you see messages appearing here, so meaning the robot is talking or interacting with a human. For some of them, you see that the robot approaches. Some of them, the person has to approach to the robot. So basically what you have here is several examples, so based on 3 tasks that we have, several examples of different behaviors of the robot, okay? And this raises the next question is, oh, no, this is the other way around, sorry. Which are the relevant or the interesting preferences? So what do we need to know from our users so then it's interesting, okay? And now I would like to do that with a little help of you. So I would like you to raise hands and so using this very nice catch thing that you have here and trying to answer this kind of question. So what do you think that it's going to be useful? So who wants to be the first one, please? Someone? Yeah?
Maybe some users prefer the robot to be more humanoid and some prefer to be like really not a human shaped.
Yeah, that's very good. So the shape of the robot determines how we are interacting with people. Yeah. Who else?
Speed of robot behavior and distance between robot and user?
Proxemics. Yeah, that's a very good one also. And do you think that proxemics is something that is fixed? So people usually like one way or another and that's it? Or while interacting with the robot, we get more confident with robots? For example, this is something that it can evolve, yeah? So some of these preferences are fixed at the beginning. Some of these preferences change over time, yeah? Anyone else wants to contribute?
Maybe that the robot judges or even tracks your behavior, your patterns, your personal patterns.
Okay, but this is a feature. Which is the problem with that? Privacy?
Yeah.
Privacy, that's a good idea. Thank you for bringing that. So there is a lot of, as you can see, there is a lot of different stuff that we can model. So we thought about that several time ago, and we come up with this taxonomy of preferences, okay? This is not a human model in the sense that we are modeling how the human behaves or how the human thinks. This is a taxonomy that tries to think which are the preferences of the person that then are useful to take decisions, because this is the part that we are interested in, okay? And you can see that we divided that in 2 different areas. One is at the bad decision-making things, so things that we believe that if we know, then we can use to make better decisions, yeah? And here, what we call about configurations. That is, once I decided that I need to approach, how I approach. Or now that I decided that I need to make an interaction, for example, how I make this interaction, okay? So this is the first proposal, and there are many others, and I will show you other things that we have been doing in this sense on how we can obtain information or which kind of information is really useful so then we can take better decisions and shape the actions in a better way, okay? So you can see that, come on. You can see that this is kind of in the symbolic world. It helps us to decide, and this is kind of on the physical world. It shapes how we are doing things, okay? But there are other ways of doing that. For example, if I really need a model of the human, I can decide, for example, here we decided 4 different human traits that then are useful for interacting. It's the memory, or the attention, or the hearing, or the personality trait, okay? This was done because we wanted to do a robot that interacts with Alzheimer patients, Okay, so in Alzheimer patients, of all the lists that, the preferences that I showed you before, it turned out that to help deciding better, then what we can do doing that is basically assume that we have what in the social sciences they call personas. So we have prototypes of people, one with better hearing, another one with some different attention span, and then what we can do with that is train our systems based on these models of people. So we don't have to basically decide for all the different possibilities, but sometimes we can train our system for few of them. Like here, I'm always taking the other way around. Like here, for example, what we had here, it was a definition of a persona and a simulator. And then what we were doing here, it was training our model, so let the model know which were the most effective actions based on these different personas. Okay? So now we have two problems here. First one is, now that I have a real person in front of the robot, to which of these personas corresponds? Okay? And for that, we usually rely on the caregiver. So we ask the caregiver, just please put some initial data about the patient. But then we have another problem, is that it's temporal. Yeah, this information can be temporal. So basically, people can change and vary all these parameters. So basically, online, what we have to do is compare the expected outcome of the actions with the real outcome, and if something is not really matching, then changing the model of the persona. Okay? Look, this can be done offline, do you see? So we don't need to online compute all these behaviors. We can compute all the behaviors offline, and then the problem only becomes a matching problem, an identification problem. Now that you have preferences, and I told you we learn how to do it, we learn how to choose actions, so how to behave. What we can do is express all the plans that we have. Okay, and this is a representation of all the plans depending on the different preferences that we have. Okay. Now we can imagine. So we put a person in front of the robot, and then we start the process. For the first preferences. Hey, do you like the robot being talking a lot or not talking that much? Hey, what do you think the robot should approach a lot or not approach? And this is quite boring for the first time. So what we propose to do is to start with no preferences at all. Okay, so we start, interacting with the person, putting a shoe or dressing as you have seen before. Okay, and as soon as we detect that some preferences could be beneficial, then we ask single preference. Okay, hey, what about this thing? And once we know that, we continue doing the task, and then we can ask eventually for a second one, and then for the third one, and this way, the interaction with the robot is more natural and more user-friendly. Do you agree? Yeah, it seems better than sitting half an hour answering questions from the robot, yeah? Yeah, I also do agree. And now that we have done this thing, we can do another thing that is a bit better. That is, instead of asking any preferences randomly, ask the preferences that provide us with more information, And this is what we did, okay? Sorry, I keep pushing the wrong button all the time. So what we did here is to demonstrate that basically we start with no preference at all, and then we keep asking preferences every time, after every execution or after several executions of them. What we obtain is every time better plans, okay? No matter if we have chosen initially randomly some preferences, okay? We always keep having better plans. And how we can decide the ordering, so which preferences is going to be here and which preference is going to be here, because we have a representation, and we know for this task which is the preference that gives us more difference in terms of reward or in terms of gains of our benefits, And we can do something a little bit better now, is that for some tasks, there are some preferences that are not that useful. Do you agree? Yeah? If there is no proxemics, imagine that the robot is not really touching anything, then the preference on proxemics basically does not care because the robot is only moving around or the robot is only talking, for example. Yeah. So now this is the right button. So this is what we did. You know, this is, for example, on the shoe fitting domain that I showed you in the. This is related to the first video that I showed you. So what we see here is that after 5 preferences, there is no gain on asking more preferences. So basically, we can decide when we ask one preference or the other that for this particular domain, these preferences are not really useful. Yeah? Which is the problem on this kind of representations? Do you see it? That everything is very task-based, yeah? For one task, some preferences are useful. For other tasks, some preferences are useful, and they are different, and they are task-dependent, okay? But this is how it works, the world in that case, you know? What we can do, and that's one of the proposals that we have, is that taxonomy that we had of preferences, some of them are global in the sense that they affect no matter what. For example, usually the person in speaking interactions, they prefer short interactions. Or when the robot is moving, they prefer usually moving fast because, you know, they want the robot being effective, okay? And then we can learn that for some particular tasks, these preferences can change. So we have kind of global and local preferences depending on the tasks. Yeah? And this is something that we can also learn. So we can use the global preferences to make our guess on how effective something is going to be. And then if there is a mismatch or something is not working, then we can kind of learn a particular preference for a particular task. Yeah. And finally, we can do something a little bit better. Is that, imagine that now we have all the preferences that we need, okay? But there is one preference that if we can change the value, then we can go better. We think that it's going to be more suitable for the person. It's going to be a bit quicker, or it's going to be a bit more interesting interaction, something like this. We can suggest, because we know which are the gains of all this, you know. So we can say at some point, I know that I'm doing this way, but if you would like to change, or you let me change this in this other way, we are going to be quicker, or we are going to be faster, or we are going to be, more comfortable, something like this. So now that we have an inner knowledge on how preferences make a role in the decision making, now we can not only ask the person for new preferences, but we can ask the person for changing its preferences, you know? Yeah. Okay, and anyone has any question about this part? Go ahead. What happened? I really like this thing. I think I'm going to buy one.
So did you consider, and if so, did you find that there are preferences that are related, where you can guess from the setting of one preference to the setting of another preference?
So you mean that if a local preferences for the task of shoe domain can be transferred to the assistive feeding, for example? That's the question?
Like, if I'm more comfortable with the robot being closer, maybe I'm also more comfortable with the robot being faster.
That would be very nice. And for that, I think that what we need to do is go to the wild, ask a lot of preferences, and then try to see. And you will see that this is very time costly, and we would like to do that, but we need more things. But yeah, that's a very interesting thing. And for sure, of course, there is some preferences that are related. And there are some preferences that we already know how they are going to change over time. Yeah. For example, usually the first day, people tend to be quite conservative with the robot. No, slow. No, don't approach. No, don't explain me everything. And after 5 days, they say, okay, now I see that the robot is safe. I see that the robot, behaves correctly. Now I want the robot to be effective, for example. So basically, we know how it's going to change over time, more or less. Yeah. Okay. So now I would like you to. I would like that we think all together on this question. Is that we have been talking about putting robots in human environments, but now how many users do we have? Because we are always thinking on the robot putting a shoe, the robot helping me to do something, the robot coming and answering me things. We work with elders, and the elders I always lose my smartphone, so I want the robot, to be able to go and look for my smartphone or my keys, where are my keys? These kind of things. Okay. But this is the only user that we have? What do you think?
I mean, if you're working with elderly people, you will have the people, nurses or other medical staff, or maybe younger relatives who are taking care of them or things like that.
Yeah, sure. So there is more than one. Yeah, I agree. So there's family, or there's the caregivers in the hospital, or there's we call it formal and informal caregivers, because family sometimes is an informal caregiver, but So what we would like is to offer tools to the caregivers so they can make things a bit more easier, and tools to the elders, so for example, they can stay longer at home, okay? And that's what we call the double loop of interaction, okay? So we have this setup, and this is an idea that we drafted some years ago in this paper. So we have a robot that is in the middle of both of them, So we have what we call the adaptive, so we would like the robot to behave differently depending on what this lady needs at some point. But we also would like that the robot takes care of what the caregiver says. And do you see the problem here? A lot of times they do not match. The caregiver says, you have to do this, and the user says, no, I don't want to do it. Okay, so here there's a problem. There's a problem that we have a cost function with two different sides, and you have to kind of balance them. And we have an ethical problem here also on who is the one in charge, okay? I'm not going to talk today about the ethical problem, but you have to know that it is here, okay? So we have proposed several ways of doing that. For example, in this scenario where this lady was using the robot to do cognitive games, because this was a robot for Alzheimer patients. What we were saying to what the doctor was saying to the robot is a kind of a level of difficulty, okay? So I would like you to put a bit more of difficulty on the game, so the person keeps engaged, because now it's too easy. Or the other way around, you need to lessen a little bit the level of difficulty, because the person is getting frustrated, yeah? So this is something that detecting that automatically with a robot, it's really hard, but relying on people to tell that to the robot is really easy. And they feel that the robot is helping them, and the robot is really helping them, you see? So let me put another example. This is 2 months ago in a real hospital, and this is a feeding robot, and you can see the person is being fed in a real robot, in a real scenario. This is real food, and this was his meal on the afternoon. So that was what he ate that day, okay? And this is what we are doing. And now I'm going to ask you about these two different people that we have around the robot. So you can imagine that one of them is this person, is being fed, okay? So he has to interact with the robot, okay? In that case, the robot is only moving, for example, if the person is looking at the robot. It's only moving if the person is opening the mouth, so the person has control on what the robot is doing, okay? But can you imagine that there is another person here, isn't it? Who is it? Is the nurse, yeah? And what do you think that the nurse has to say in how the robot behaves? The time, Okay. What else? Can you imagine? Everyone is looking at the video and not looking to me. I don't know why. Go ahead.
There's points where the robot has to stop, but the patient is unable to tell the robot to stop because maybe the patient is still opening his mouth or looking.
Okay, so there's the termination. So our robot detects that there is no more food, and then basically it stops. But there is other termination occasions, yeah. So, oops, ooh, that was dangerous now. So I see the problem, the drawbacks of the system. No. Yeah. Almost spilled. So you see here, it appeared, our simple interface, okay? So for some people, they don't want to eat. And for some people, they basically eat very nicely or, no problems. So basically what the nurse says is which level of insistence the robot has to have, yeah? So if the person eats nicely, then if today don't want to eat that much, we don't care. But if the person really needs to eat or gets distracted very easily, then the nurse can say, no, you have to insist a bit more because this person needs to eat because of its condition or because it gets distracted very easily and then, it needs to be remembered. So we ask them the degree of insistence or the importance on the meal, let's put it that way, which is this meal really important or not? And from that, then we reshape the behavior of the robot. It has some insisting mechanisms, It looks like this, it makes sounds, hey, look, it's your turn. It has different strategies to keep attention, And then we reshape these strategies and we kind of change the timeouts, let's say that way, depending on what the nurse said, okay? So this is a very nice example on a double lobe of interaction also. Can you see it? Yeah? Okay, and now I would like to continue on saying, as I said, I'm not going to talk that much on the social part, on how we measure that, on how we pass some tests to the user to understand which is the effects of the robot in the meal. This is a talk for another day. Today I would like to go a little bit more deeply on the technical things, okay? Because if you go to the conferences on the community, there is a lot of papers talking about trust, talking about how to do it, but then at the end of the day, everything is scripted, yeah? So the robot has been scripted to have two different behaviors, and what they measure is the two different behaviors, which is nice because we have knowledge, we have insights on the effects, okay? But no one is really cared that much on how using effectively on the fly and computing autonomously, these two behaviors, okay? So I would like to make a bit of a stress here, just maybe to inspire you in doing something similar, if you can. Okay, so I'm going to show a couple of examples. Here, for example, what we have is we have a user. It's not really a user. We have a co-worker of the robot here, okay? And what we show is that we use preferences to make a plan for both agents, okay? And when something happens, this plan basically reshapes. For example, now this is our model of the user. You see we keep changing the model depending on the task. And basically this is knowledge, capacity, and motivation. This is an offline measure on how well both agents can do things, an online cost function on how things are from this moment, and the motivation. So if the agent seems that it's willing to do that or basically not. And based on that, what we do is using classical planning. So this is PDDL and a classical planner to generate two plans, okay? One plan for the robot and one plan for the human, okay? And what happens if there is a change on this, okay? Imagine what we are gonna see on the video is the person wants to do his part, but then gets distracted. So basically one of these three parts, what we call motivation. Motivation is a kind of a sum up of a lot of things, We have a lot of things and then we came with a nice single parameter. It's gonna change, so basically what we're gonna do is change the plan, okay? So we changed, then we replan, and then we come up with a new feasible plan, okay? And this was starting the video, yeah. Okay, so you see what I said, okay? They were supposed to move things here, but there is a distraction, so basically what we see is that this is not gonna happen anymore, and then basically the robot has to do everything, and this is what's gonna happen, yeah. Okay, what's missing here? Any idea on what's missing here, on what I showed you? Come on, detecting flows on others' work. This is, our most... There is no human-robot interaction, so how the user knows which is the plan?
The collaboration between the robot and the human about the task they want to do.
So they were collaborating, but because they had the same goal, but not really interacting for the action. Okay, so the kind of tasks was kind of limited in this example, but basically they can collaborate more physically, and it still holds. Okay, but for sure, if we include these kind of actions that you were telling, then we need to share which is the action and to share. So there is a lot of human-robot interaction that here is missing. Yeah, so that was the missing part here. Okay, but it was a nice example based on a very simple model of a human, how we can basically do the rest of the things, and this is automatic. Yeah, and the paper will have examples on other areas. Here you have a different model. Now, instead of 3, we have 5. You see, knowledge, dexterity, strength, focus, and vitality. So basically what we have is a human. Again, this is taking the idea of the previous paper, so we have personas, okay? And we have, which is the profile of this persona, based on, you see, a very, very brief, it's not really very, very detailed. Very brief description on Rachel, on that. And then we have the agent model, and for each one of the actions, we have which is the characteristics that are relevant for this action, okay? For some of actions, you need strength. For some of them, what you need is dexterity, for example. Yeah? So basically, if we have that, now we can easily compute this, yeah? Do we agree? Yeah, so we can easily compute that, So for selecting ingredients task, this is, the probability of success for this person based on this model of selecting ingredients, whereas for Nick Dolph, you need to work with the hands. This is going to be the different probabilities. Now, what happens if we change the kind of persona? Basically, we can recompute everything, yeah? So if you change the persona based on the same task, then you have a different outcome. You see? Okay, which is the beauty of the thing, is that we can compute everything offline again. So we can have 270-something models, that is what we have here. Everything computed offline, okay? As before. Now the problem is which of the 270-something models is the relevant one when I'm interacting with a person. And this is, we have converted the problem of, generating a lot of knowledge in a problem of identification, yeah? Because all these agents can be seen in a continuous way. We can also see this identification plus online changing as navigating through the space of people. Do you see it? It makes sense to you? Yeah? So basically, we are in a point in the configuration space of people. And if something does not work, we can, look at the neighbors and look which is the neighbor that feels better what we are seeing, and then changing this model there. And this is how online we can change the behavior of the robot with zero computing cost, or only the identification cost. But we don't have to basically compute everything again. Can you see the beauty of the thing? Yeah. Okay, and now I'm gonna stop again in another example. I've been talking to you a lot about this robot on cognitive training for Alzheimer patients. Let me show some videos, okay? So this is how it works, again, with the same idea of having an offline learning paradigm and everything and blah, 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 and an online part where what we are doing is navigating through this model. So you see that we are doing that quite a lot, yeah? And this was published this year recently, but the work is a bit old. By the way, this is the work of a PhD student that already finished and currently has the George Giralbi's PhD award in robotics in Europe, so this year. So this is the work, okay? And to me, it was awarded this year because it had a correct mixing between social, a lot of real experimentation, more than 600 experiments with real people, But on the other way, a lot of AI and robotics strength and propose very nice methods. So it was kind of something in the middle. And I think that the jury appreciated that point, okay? So let me go direct to the experience. So this is what we did. So this is the patient with the real doctor, and this is the game, okay? And if I have opportunity and you ask me why the game has this shape, I'm gonna tell you. And this is the robot doing exactly the same, okay? So what we can see here is the doctor. So basically this is ordering in ascending order, you know, and the robot, the caregiver is providing some interactions. Have you seen that the interactions are non-verbal sometimes? So the person is nodding a little bit, and you see now he's providing some help. You know, look there. We did the same with the robot. You know, look there. So this is how we mimic the caregiver with our robot. Okay. So what's the challenge here? So the challenge here is to change the behavior of the robot depending on the situation of the person. And this situation changes. You see, over time, the game is easier. There are left parts to be put it on, okay? So it's easier, okay? But we have more knowledge if the person gets distracted or the person gets wrong a lot of times, you know? So selecting the right amount of help, this is really the challenge on this situation. Okay, and I'm going to show you now the results, but before let me show you that we did that with several patients in COVID time. So you see everyone covered. It was really a nightmare. So every time we finished one experiment, we had to clean everything and, you know, drop everything. So you can imagine the difficulties on getting all these results. And basically the results are these ones. I'm going to stop basically here, okay? So this is what I want you to look at, okay? So what this represents is the similarity between plants, okay? And what it shows is that when you have a therapist, because this is, you know, stronger blue, plants were more similar to one to another, okay? So what basically says is that no matter which patient was, you know, the therapist has kind of 2 or 3 ways of doing things and just basically switching between these 3 modes, no more than that, you know? Whereas the robot, you know, you see less blue, you know. The robot can basically tailor better the assistance to the different patients, okay? And before I change, do you see the trick here again? You have to always think that presenters are always trying to trick you. So which is the trick here? And that's true no matter what, you know? So which was the task? The task was to train patients, so basically the cognitive decline is less. But this is not what we have shown here. We have shown here that the robot is able to adapt better or not, which is nice. The robot adapts better. We don't know if this has a positive effect on the person or not. So this is the trick, okay? It would be very nice to do that, but it requires a really complex and long user experiment with patients, and that's not easy, okay? We will try, okay? But that's a trick, yeah? Okay, and I'm gonna go directly to the end. So I would like to talk a little bit about generating explanations, because we have been talking about communicating, okay, and explainability and explainability in AI, it's a very nice topic, and how to do these explanations automatically is really a challenge. And what we are doing now is basically go to descriptions of the plan or contrast it between one plan and the other, and I will try to show you what we have tried to do to try to go beyond mere descriptions of the plan, okay? So you can see this is a video of a robot doing a task. Let me see if it works. No. So basically it's, can you bring me a drink? You know, and the robot basically then goes to the kitchen and does all the stuff, okay? And based on that, this was a video that we were showing to people. Then we were showing a list of questions and some explanations, okay? And what we were asking is, Based on that explanation, this is what you can see. This is reasonable based on what you have seen or not. Okay? So basically what we do is, we do that, and so we have a kitchen. It's not that big as the one that you have here, but it's our kitchen. It's a lab kitchen, and we were using that in the lab, not the regular kitchen. So you see we have kind of a mock-up of an apartment also. Okay, now these are the kind of explanations that we were able to do. So what did you do? And this is basically the explanation. I moved, and this is just a description. I said that we wanted to go beyond. Why did you move? Because, the kitchen was there. Or what do you fail to pick the beverage? So we were showing one part of the video where the robot tried to do it, and basically, what if you do it, you pick. If you fail, then basically the planner was just replanning, not having a second thought, so doing it again. Or why did you hand over? Because it was part of the goal. What did you fail to pick the beverage? And basically what we did was disconnecting the camera from the robot, so this was real. So all these explanations come from a real system, and they are generated automatically from the inner states, okay? First trick, we are getting that with triplets of actions and precondition or states and expected results, but these are very nice sentences. We are using ChatGPT for that. Okay, so it's not that we are asking ChatGPT, we don't show the video to show, we are providing ChatGPT with triplets, so these are the relevant states, and what we are asking is convert that to a nice sentence. So I think it's a fair use of ChatGPT. Do you agree? Yeah? Do you agree or not? Yes? Okay, so it's a fair use of ChatGPT. Things are pretty much low level yet, do you see? There is no real, I promise you going beyond the description, and this is still descriptions, yeah? There is no cognitive level, or there is no abstraction that much here. Do you see? So how can we go to these kind of abstractions? So what we do is do an ontology where we wanted to model collaborations and plan adaptations, okay? And this is how we modeled the thing. So you have this collaborative task between a robot and a person. We generate a knowledge that is based on this ontology, so we have all these tags. And then we used our ontology plus the episodic memories. So we have now not only how we generate things, but all the memory. And finally, we generated some retrieval of information and the generation of explanation. Why this is important? Because now this is not anymore, this is in my plan, or this is part of the goal, or this kind of descriptions. This is, I detected a collaboration, and this is on another level. Do you see it? Yeah? Although still is limited, this is another level. So we have different levels of interacting with our ontology and levels, and you can imagine this is a short, a medium, and a long explanation, and this is the fantastic result. Do you like it? Come on, this is incredible. We have extracted information from an ontology, and we have created some explanations. It's amazing. Why these faces? Come on. Yeah, it's horrible. I agree. It's horrible. But here, I showed you before, we can just turn that into nice sentences, okay? I wanted to show you here, the origin of everything. So this is basically what we can extract, but and in different levels, okay? And sometimes this is repeated, and I know, okay? The key ingredient here is that the important information about this being a collaboration is here, okay? And this has been automatically extracted from the episodic memory and the knowledge and ontology, okay? And now, this is only a matter of converting that to a nice sentence, okay? But the key ingredients are here, yeah? Okay. I just wanted to include a brief point on a new lab that we are creating. I'm going to go really quick. So our question was, okay, assistive robotics is very nice. I have shown you robots in a hospital feeding, and we have robots in oncology, and we have robots in Alzheimer. That's very nice, but are they really there? What do you think? No, you cannot go and buy robots in the market that does things, okay? Why? There is several reasons, and what we want to do is, with this lab, trying to figure out which are the reasons, okay? So we have a new infrastructure, we will have an apartment inside of and this is gonna be a real apartment, you know, with all of appliances. And more importantly, what I wanted to show you here is we have several partners. And these partners are hospitals, it's the municipality, it's caregiver companies, it's elder associations, other labs, robotics companies, all this stuff, okay? Why? Because we believe that this is the only way that we can find what to do, how to do it, and when to do it in an efficient manner, you know? So only in some takeout messages for today, and that's my last slide, I promise, okay? Preferences, I think, are useful, you know? If we know several things and we can, you know, if we know how to do, what to do with them, okay? Explanations, do we agree that explanations seem important, isn't it? Yeah? There is someone thinking explanations are a bluff and this is gonna go nowhere? No, okay, or at least you don't want to declare that. Okay, explanation seems to be important, but we don't know how to generate them, and we don't know how them can be effective in a interaction, okay? So I showed you some ways of automatically generating them, some of them prettier, some of them a bit uglier. And I wanted to stop just here as a reflection, okay? Explainability in artificial intelligence is different from explainability in robotics. And to me, in robotics, it's much more interesting, okay? Because we have multiple sources of information. It's not just about the algorithm, how it's decided. It comes from the perception. It can come from the actions. Actions are not deterministic. And there's plenty of ways of retrieving information that is useful for explanation. Why the robot has failed, you know? Why I don't have the more touch. That's neat and clear, you know? I can go there and see the decision. Why the robot failed, yeah? And to me, that's also important. It can happen multiple times. So it's not, I go to the bank, I have a mortgage, I have an answer. It's the robot is doing something, while it's doing something, I ask, but then when it's continuing doing something, I ask again, and maybe at the end, I can ask again, okay? So to me, fundamentally, this is a very interesting problem, okay? And finally, I would like to make a point here on trying to do real experiments with real people and having your stakeholders always in hand, because a lot of inspiration comes from when you go there, you see things not working, and then you have to come back to the lab and, you know, doing all these things. So have stakeholders at hand. If you don't have them, then go to a facility like the one that I showed you, like the lab that they are creating here. So go to a facility to make sure that you are in contact with your stakeholders. And I think I have some minutes for questions if you would like.